In this video, we will explore C++ structures. I will explain how to define and use structures to group related data together. So, what exactly is a structure? In C++, a structure is a user-defined data type. It lets you group related variables under a single name. Structures can organize data of different types, allowing you to create complex data structures and model real-world entities. For example, here's a simple structure named student. It contains a string for the student's name, an integer for their ID, a float for their grade point average or GPA, and a boolean to indicate if they are currently enrolled. Remember to include the semicolon after the closing curly brace of the structure definition. Once you have defined a structure, you can create variables of that structure type. Here's how. First, we define a structure called person, containing a string for the name, an integer for the age, and a float for the height. To declare a structure variable, you simply write the structure name followed by the variable name. For example, person1 declares an uninitialized variable named person1 of type person. You can also initialize the structure members at the time of declaration. For example, person2 equals followed by an open curly brace, then Alice 25 and 5.7 enclosed in curly braces. This will initialize person2's name to Alice, the age to 25, and the height to 5.7. Remember, you can assign values to structure members at declaration or assign values later. To access the individual members of a structure, you use the dot operator or period. Let's see how it works. First, declare a variable person of type person. Then you can assign values to its members like this: person.name equals Bob, person.age equals 30, person.height equals 6.2. Similarly, you can access member values and store them in variables. For example, string username equals person.name. This assigns the value of person.name, which is Bob, to the string variable username. You can both read from and write to structure members using this operator. Each member behaves like a regular variable of its declared type. Structures can also contain other structures as members. This is known as nested structures. This allows for creating complex, hierarchical data structures. In this example, we have a structure called date, containing integers for the day, month, and year. Then we have another structure called employee, which contains a string for the employee's name, an integer for the employee ID, and two date structures, one for the birth date and another one for the joining date. To access the nested members, you use multiple dot operators. For example, employee.birthdate.year. You can create arrays of structures to store multiple related objects. In this example, we have a structure called point, which has two integer members x and y. Then we declare an array of point structures called points with a size of 5. Each array element is a complete structure. You access individual members using the array index and the dot operator. For example, to access the x-coordinate of the first point in the array, you would write points of 0.x. These are useful for collections of similar objects, and you can iterate through the array with loops. Structures can be passed to functions as arguments and also returned from functions. Here we have a structure called rectangle, containing doubles for the width and the height. The function calculateArea takes a rectangle structure as a parameter and returns the area of the rectangle. The function createRectangle takes two doubles, w and h, as parameters and returns a rectangle structure with the specified width and height. By default, structures are passed to functions by value, meaning a copy is made. For large structures, consider passing them by reference for better performance. You can also create pointers to structures. Here we have a student structure with a string name, integer ID, and a float grade point average. We create a student variable called student1 and initialize its members. Then we create a pointer to the student structure called ptrStudent and assign it the address of student1 using the ampersand operator. To access the members of the structure using the pointer, you can use the arrow operator. For example, PTR student arrow name. Alternatively, you can dereference the pointer using the asterisk and then use the dot operator. For example, *PTR student.GPA. Pointers to structures are useful for dynamic memory allocation and efficient for passing large structures to functions. In C++, structures can contain member functions in addition to data members. This brings us closer to the world of object-oriented programming. Here we have a structure called circle with a double radius. It also has two member functions, area and circumference. The area function calculates and returns the area of the circle, and the circumference function calculates and returns the circumference of the circle. Member functions have direct access to the structure's data members, making it easy to perform operations on the structure's data. Here are some best practices to keep in mind when working with structures. Use meaningful names for structures and their members. Group related data together in a single structure. Keep structures focused on a single purpose. Consider using member functions for operations related to the structure's data. For large structures being passed to functions, use constant references to avoid unnecessary copying. Initialize all members when creating a structure to ensure consistent and predictable behavior. Structures are ideal for grouping related data such as coordinates or personal information, representing real-world entities such as products or users, returning multiple values from a function, creating custom data types, building more complex data structures, and organizing data in a meaningful way. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.